So guys, welcome to our channel once again. We have here these 10 questions to answer on the topic sound waves. So ensure to stay till the end of this video. Let's go ahead and start with the first question here. It says, a note produced by an instrument distinguished from a similar note produced by another instrument by the A. pitch, B. loudness, C. intensity, D. overtone. So guys, the answer to this question is option D here, overtone. So let's go ahead and consider the next question. So the next question is question number 2. It says, thunder is usually heard some seconds after lightning is observed because, okay guys, the reason for this phenomenon is actually because light travels faster than sound. So that's option C here, guys. Take note of that. Let's go ahead and consider the next question. So the next question here, question number 3 says, which of the following diagrams correctly illustrates the vibration of air column in second harmonics in an open pipe? Alright, so guys, the answer to this question is going to be option A here. Now, in order for us to verify this, actually we need to understand that for second harmonics, lambda is equal to 1. So for this structure in option A here, if we sum up this, we're going to have lambda over 4 for the first here, which is actually a half. So the second here, which is complete, we have lambda over 2. Then the third here, we have lambda over 4. So lambda over 4 plus lambda over 2 plus lambda over 4 will give us 4 lambda over 4. Alright, so we'll equate 4 lambda over 4 to 1. So we'll divide the 4 here by 4, and then we have that lambda is equal to 1. So this is verified. Option A is the answer to this question. So let's go ahead and consider the next question, guys. So the next question here is question number 4. It says, a tuning fork of frequency 600 Hz is sounded over a closed resonance tube if the first and second resonance position are 0.130 and 0.413 meters respectively. Calculate the speed of sound in air. Alright, so guys, the speed of sound in air here is actually going to be 2 times the frequency times the change in length. So that's 2L into L2 minus L1. So guys, for this, we're going to have the change in length to be 0.413 meters minus 0.130 meters, and that's like 0.283 meters. So in this situation, we are going to have 2 times 600, which is the frequency, times 0.283 meters. So guys, let's go ahead and calculate that. So that will give us 339.6 meters, and that's option D here. So let's go ahead and consider the next question, guys. Alright, so guys, the next question here is question number 5. It says, the diagram below illustrates a mode of vibration of a wire of length 125 cm. The spread of the waves across the wire is actually 120 meter per second. Use the diagram to answer questions 39 and 40. Alright, it says here, determine the wavelength of the waves. Alright, so in order for us to determine the wavelength here, we have to recall that wavelength lambda is actually the length here over the number of complete oscillations. So guys, 125 cm here is actually going to be converted to meters since all the answers here are in meters. So one will do 125 cm to meters. That's going to be 125 over 100, and that's 1.25 meters. So one will divide 1.25 meters by 2.5. That's going to give us 0.5 meters. And that's option C here for this question. So that's it here. Option C is the answer to this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says, a sonometer wire of linear density 0.08 kilograms subjected to a tension of 800 newtons is plugged. Calculate the speed of a pulse which moves from one end of the wire to the other. Alright, so guys, this is actually simple for us to do here. The speed here will be equal to the square root of t over mu. So where t is 800 newtons, that's the tension here, and mu is the linear density, that's 0.08. So that would be the square root of 10,000, and that's 100, guys. So option A is the answer to this question. Let's go ahead and consider the next question, guys. Alright, so guys, the next question here says, the velocity of sound in air is 15 degrees Celsius at 340 meters per second. That's 27 degrees Celsius. Okay, this will be the velocity of sound in air is 15 degrees Celsius at 340 meters per second. So what's the velocity at 47 degrees Celsius? So guys, in order for us to calculate this, we have to recall that the velocity of sound is actually directly proportional to the square root of the absolute temperature. So in that case, we can say that the velocity varies at square root of t. So if we want to use this to solve out, we are going to have that v1 over t1 is equal to v2 over t2. So where v1 here is actually 340 meters per second, then t1 is actually 15 plus 273, because this should be in absolute temperature. So we have to add 273 to convert it to Kelvin. So that's 288 Kelvin. So where V2 is not given and T2 is actually 47 plus 273. So that's 320 Kelvin. So in that case, if we apply this to the formula, we are going to have 240 over square root of 288 is equal to V2 over square root of 320. So if we make V2 the subject of this equation, we are going to have 340 times square root of 320 all over square root of 288. So guys, we're going to have 358 meters per second, and that's option D here. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question here is question number 8. It says, the main portion of the mouthpiece of a telephone is to convert sound energy into A, chemical energy, B, light energy, C, heat energy, D, electrical energy. Alright, so guys, the answer to this question is option D here. The mouthpiece of a telephone has the major function of converting sound energy into electrical energy. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question here is question number 9. It says, which of the following is a wind instrument? We have A, guitar, B, violin, C, piano, D, organ. So guys, the answer to this question is option D here. That's the organ. Organ is a wind instrument. And that's it for this question. Let's go ahead and consider the next question, guys, together. And that's the last question for today. So the next and last question, guys, here is question number 10. It says, a listener can dictate the instrument from which a note is being sounded because different instruments produce the same note with different A. frequencies, B. pitches, C. loudness, D. overtones. So guys, the answer to this question is option D here. That's the overtones. And that's it for this question, guys. This will end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.